Okay, so b divided by -1 is just negative b, and negative a divided by -1 is positive a. So I've just basically divided both of them by -1. Another way of thinking about that is factoring out a -1. So I leave that -1 outside, and I can just rewrite this as a minus b. And look, now I have the same thing on the top and the same thing on the bottom, but I'm left with a -1. So this is an important thing. So other examples of this, if you see like 2 minus x over x minus 2, that equals -1. Okay, anything where you have the same numbers or variables, but they're just switched with a negative, it results in -1. You might want to highlight this, put a box around this, star it. It's a very important conclusion that comes up quite a bit in your work, and definitely on your tests in your exam. So to simplify, first we factor, okay, the numerator and the denominator. Then we note any restrictions, because again, the restrictions come from the original denominator. Then we remove any common factors. Okay? And then we include restrictions in our final answer. Now, if you're up to it, I would suggest you could pause the video at this point and try some of these examples in pencil or on a separate piece of paper to see how much of this you actually understand, and then go through and watch to make sure that you got it right. Okay? Alternatively, if you're really confused, I would put down your pencil right now, watch me do the example, then pause it and copy what I have up here. I just find that if you copy while I talk, you're not really taking in what it is I'm actually doing. Okay, so in this case, again, you always do the numbers first. So 25 divided by 5 is 5. X squared divided by x is x, and y divided by y is 1, so you're just left with 5x. Okay, and you know that x cannot equal 0, and y cannot equal 0 in the denominator. Okay, 4x, we can't factor out anything on the top, but we can do common factoring on the bottom. So we can factor out a 4x, then we're left with 4x squared minus 3. Okay, so notice these cancel out totally, so that leaves a 1 up here. So you're left with 1 over 4x squared minus 3. Okay, so how do you do these restrictions? Well, you have to set these two factors equal to 0. So 4x cannot equal 0, so therefore x cannot equal 0. And then 4x squared minus 3 cannot equal 0. So therefore, x squared cannot equal 3 over 4. Okay, move over the 3, divide by 4. So x cannot equal the square root plus or minus the square root of 3/4. Okay, so a 0 and then a plus or a minus root 3/4. Those are the restrictions. Any of those values would make this denominator 0. And here's your simplified expression. Okay, just a few more examples. Okay, 3 minus 2x and 4x minus 6. So let's common factor what we can. There's nothing to do on the top, but on the bottom, notice we can common factor out a 2. Okay, so what do you notice here? A 3 minus 2x and a 2x minus 3. So we can cross those off, but we can't just cross them off and leave a 1. We have to leave a -1 in its place. Okay, because again, it's 3 minus 2x and then 2x minus 3. So we're left with a -1/2. Okay, now our restriction here, 2x minus 3 cannot equal 0, so x cannot equal 3 over 2. Again, you move over the 3 and then you divide both sides by 2. Okay, there you go. This is actually the example I started with. There's y's here instead of x's. So how about you go ahead, you try to factor this on the top and on the bottom. Okay, So you're left, you get two numbers that multiply to 15 and add to negative 8. So y minus 5, y minus 3. And then two numbers that multiply to 10 and add to negative 7. So y minus 5, y minus 2. Okay? Y minus 5 is common to both the top and the bottom, so it gives you 1. So you're left with y minus 3 divided by y minus 2. But y cannot equal 5 or 2. There you go. Okay, one more example. Okay, 10x cubed quarter. Okay, so this is a quartic, so you might freak out and say, I don't know how to factor that. But notice that every term in the numerator has an x. So let's just start by taking out common factors. So 10, 8, and 4 are all divisible by 2, so I can take a 2 out. And they all have at least one x, so I can factor an x out. So then I'm left with 5x to the power 3 minus 4x plus 2. Okay, so to make sure you've done that correctly, just quickly in your head multiply this back to make sure you get back to the original. 2x times 5x cubed is 10x to the power 4. 2 times 4 is negative 8. X times x is x squared, so that works. This times this, 4x, good. Okay, and on the bottom I have 2x squared. So notice I can cross out the 2's, and I can cross out one of the x's. So I'm left with just 5x cubed minus 4x plus 2 all over x. Now, can this be reduced any further? No, it can't, because there's nothing common on the top, and there's only an x on the bottom. So we're done. X cannot equal 0. All right, so that is the note on simplifying rational expressions. So your basic, what you're doing here is just trying to get something that's commonly multiplied in a numerator and a denominator so that you're able to cancel them out because they divide and give you 1, so you're able to cross them off, leaving something that doesn't look as scary and ugly and awful. It's a bit simpler. This will be very useful next year in some of your graphing and your problem solving, but you always have to make sure to state your restrictions, which is any x value that would make the denominator 0, because we can't divide by 0. Thanks so much for watching, and I hope you learned lots.